Let us continue the discussion on Lewis structure. In this video, we will explore more into exceptions to octet rule. We can classify the exceptions compound into three. First one is less than 8 electron, and the second one is more than 8 electron, and the third one odd electron compounds. So we are going to concentrate in this video on the less than 8 and more than 8. Odd electron compound we will discuss in another video. Let's see an example with a less than 8 electron on the central atom. So the first example here we are seeing is BF3. In BF3, how to draw the electron structure for BF3 is, look in the periodic table for boron. Boron is in the 13th group, so you can see 3 valence electron. And for fluorine, it's in the 17th. So we have 7 valence electron. There are 3 of them, so total 24 electron, right? So that means 12 pairs. How to draw? The central atom will be boron because fluorine is the terminal one, and also that's the highly electronegative element in the periodic table, so it cannot be in the center. So I took already the 3 pairs out of 12 pairs here. So where am I going to put the lone pairs? We will put the lone pairs on the fluorine. Okay. We can see there are 6 I took. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All 12 pairs I used. And now when you count the number of electrons around each element, you can see for fluorine we have 8 electrons. And for another fluorine 8 electron, this one is also 8 electron. Whereas for boron we have only 6 electron, and that's okay in this case because boron is a small element in the periodic table. The size is very small, so it cannot hold. It is okay to satisfy with a 6 electron around boron. So smaller size is the reason. So you can take another example of beryllium chloride. So beryllium chloride, you can throw BeCl2. Beryllium, we have 2 valence electron because it is in the second group. Chlorine, we have total 14 because it is in the 17, so we have 2 of them, so total 16 electrons, so that means 8 pairs. So how can we draw that one is, boron will be the center, beryllium will be the center atom, and then chlorine and chlorine on both sides. So we have out of 8, I used 2 already, so we have 6 left. So we can put the lone pairs on chlorine. So 6 pairs I put. So total 1, 2, 3, 4, 5, 6, 7, 8 pairs I used. So how many are there on each? We have 8 here, we have 4 here, we have 8 here. So that's okay for beryllium chloride as well because it is the smallest, very small element, and it is okay to have less than 8 electron on the central atom. So if it is very small, it is okay. So normally these 2 examples we explain for less than 8 electron on the central atom. Here is an example for more than 8 electron on the central atom. So when I talk about more than 8 electron, you have to pay attention here. Whenever the element is coming, so the phosphorus, right? Here it is phosphorus and chlorine. So phosphorus, where is phosphorus? Here, correct? So phosphorus is in the 3rd period. Even though it is in the 15th group, it is on 3rd period. So any element from 3rd period and above, that means 4th period, 5th, 6th, and 7th period. If any element under this period can hold more than 8 electron, up to 12 electron, the reason is that contain d orbital. So d orbital can hold more than 8 electrons. Okay, that's the reason. So pay attention to that one. So let us try an example here. So the example is PCl5. Phosphorus is in the 15th group. So phosphorus will have 5 valence electron, and we will have chlorine with a 7 valence electron. We have 5 of them. So the total will be 40 electrons. So that means we will have 20 pairs. Let us see how to draw that one. So who is going to be the central? Phosphorus, because you can see that phosphorus is away from fluorine. So phosphorus will have less electronegativity than chlorine here. Chlorine is closer to fluorine. So let us draw the Lewis dot now. So what I will do, I will connect all the 5 chlorine first. Okay, so chlorine, 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 and chlorine. So 5 chlorine, and I used 5 bond pairs, 1, 2, 3, 4, 5. So out of 20 pairs, I already used 5 pairs. So I have 15 left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 pairs I put. So total 20 pairs I used, and you got the Lewis dot structure for PCl5. And when you count the number of electron on phosphorus, you can see 2, 4, 6, 8, and 10 electron for phosphorus. It can hold 10 electron because it has a d orbital. So this is a good example of a molecule which can hold more than 8 electron on the central atom. Okay, so it violates octet rule, but still that's okay because of the d orbital. Now you try this example to check your understanding SF6, because all the rules are same and everything is same. We are just actually doing just an exception, right? So SF6, you try which group and period it belongs. So think about it and try and see you are getting the answer. You can pause the video here, and after you are done in your notebook, check your answer. If you are getting this one, very good, excellent, you did a good job. So that means you learned how to draw with an exception. If the molecule is in front of you with exception, that is exempted from the octet rule, how to draw you know now, and how to decide whether it can hold more than 8, because S, that is sulfur, is in the third period, and then it can hold more than 8 electron. Okay. So far we have discussed Lewis dot structure and how to represent ionic compound using Lewis symbols, and how to draw Lewis structures for covalent compounds that obeys octet rule and that doesn't obey octet rule. And under doesn't obey octet rule, compounds for the central atom with a more than 8 electron, and we have seen compound with a central atom that contains less than 8 electrons. And in the next video, we will explain resonance, formal charge, and free radicals. Thank you for watching this video and learning how to draw Lewis dot structures.